The topic of this video is rectangular to polar conversion examples. In this video, we will convert points from rectangular form, x, y, to polar form, radians, theta. We will do two examples. Let's do the first example now. Example 1. Convert -3, 2 to a polar point. It is extremely important that you do a rough sketch of the point whenever you convert from rectangular to polar. You'll see why at the end of the problem. Now, you need two equations to convert from rectangular to polar. One that you plug in the x and y values in to get r, and another that you plug the x and y values in and get theta. These two equations are r equals the square root of x squared plus y squared, and theta equals the inverse tangent of y over x. If you'd like to know how we found these equations, watch the video Polar and Rectangular Point Conversions Part 2 on my YouTube channel. Now, let's find r. r equals the square root of x squared plus y squared. And for this problem, let's plug in our x and y values. So r equals the square root of -3 squared plus 2 squared. And if we keep on simplifying this, r equals the square root of 9 plus 4. So r equals the square root of 13. So we found r. Let's find theta. So the equation we use for that is theta equals the inverse tangent of y over x. So for this problem, theta equals the inverse tangent of 2 over -3. So if you plug that into your calculator, make sure it's in degree mode, you get -33.7 degrees. And if we look at our drawing, this is where you have to be careful. This is clearly not -33.7 degrees. -33.7 degrees is actually the angle in this quadrant. The calculator just gave it to us in a quadrant we don't want it in. So now you have to add 180 degrees to get this angle in the correct quadrant for this problem. So this is a very important step. You don't want to forget that. And you know that this is the wrong angle because it doesn't look right on your drawing. So if you add that 180 degrees, you get your theta equaling 146.3 degrees, which is the correct angle for this example. So your answer for this problem is the square root of 13, 146.3 degrees. So that is how you solve example 1. Let's do example 2 now. So, example 2, convert -4, -5 to a polar point. In this problem, just like the last one, it is crucial that you do not forget to sketch your your rectangular point. That is a crucial step. So, let's go ahead now and find the r value. So r equals the square root of x squared plus y squared. So, if we plug in the values from this problem, r equals the square root of -4 squared plus -5 squared. So if we keep on simplifying this, r equals the square root of 16 plus 25. So r equals the square root of 41. Now let's find theta. Theta equals the inverse tangent of y over x. So if we plug in the values from this problem, theta equals the inverse tangent of -5 over -4. And that is the same thing as saying theta equals the inverse tangent of 5 over 4. So plug that into your calculator, and it will show you theta equaling 51.3 degrees. Now this is a step where we have to be careful again. If we look at 51.3 degrees, that is not this angle. That angle would be much larger. 51.3 would be in the first quadrant here. So the calculator did not give us the correct one we wanted for this problem. We will have to adjust it by adding 180 degrees, just like the last problem, to get this angle right here. And when you add that, you get theta equaling 231.3 degrees. And that is the correct angle for this example. So your answer for this problem is the square root of 41, 231.3 degrees. And that is how you solve a rectangular dipolar problem. So the main takeaway from this that I do not want you to forget is do not forget to double check what your calculator gives you with your drawing, because it may give you the answer in the wrong quadrant that you need for your example.
If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.